Okay, so we are ready to get started on the next page of notes, and this is going to be talking about the property of gases, and so we're going to explain what each property is as we go along here. So the very first property is the expansion of gases, and probably most of you know that gases do not have a definite shape or a definite volume, that they're going to completely fill any container that they're in. And with that in mind, if you think about it, if you have gases that are in a small bucket and then you take them and you exchange them or pour them into a larger bucket, they're going to completely fill then that bucket. They're just going to move further and further away from each other until they fill that bucket. And so gases expand to fill their container. Okay, our next property is fluidity. Because of the attractive forces between the gas particles are significant, gas particles, we say, will glide past one another. This ability to flow, that's what we call that, causes the gases to behave as a liquid do. And because liquids and gases flow, they're both called fluids. Okay? So again, it is that ability of gas particles to slip one past another that we say they have the ability to flow, and therefore they are a fluid. Okay, and again, as I was writing this down, I think I said are significant, but I might not have. So again, the attractive forces are insignificant, and again, the ability to flow is why they are fluids. Okay, in terms of density, the gas particles, again, are very, very far apart. A lot of empty space within the gas particles, and therefore they have a very low density. The next one is compressibility. So we've kind of already hit that on the last one. Again, because of the so much empty space between the gas particles on there, that if we pressurize it, we can kind of basically push out those gas particles and compress the gases into a smaller area. Okay, and we again may or may not have talked about marshmallows when we do that, and the fact that marshmallows are full basically of air, and so we can actually pressurize those and make them a lot smaller, and again that pushes out the air. Okay, and then I also gave you a little picture there. So if you think of it, I put here like 5 gas molecules and a large area. And again, we can compress those down 5, take the space out, the empty space. We don't want to call it air, although we do kind of say air sometimes, that word, but empty space between the particles, we take those out. We can compress those 5 molecules there closer together. Our next word is diffusion, and again, because gases spread out very easily on their own, they take the shape of the container. So if you take the lid off, let's say, and they're not contained, then they are just going to continue to spread. So if you think about it, if somebody sprays some perfume, then we smell it within the whole room, because it doesn't take. If somebody's baking cookies in the fax room, then we'll smell it all the way down the hall, because again, those fumes, those gases will continue to travel if they're not contained within some sort of container with a lid on it. We call that diffusion. Okay, so I recorded the random and continuous motion of the gas molecules, carry them throughout available space, and gases will readily diffuse one into another and mix. So that would be like, again, the perfume into the air. That is 2 gases that are mixing, again, because of the random motion that we have. Okay, our next word is going to be effusion. Effusion is when our gas particles, they don't spread out and just go anywhere, but they actually go through a tiny opening. So gas molecules, again, they're so spread apart, they're so small that they can slide through tiny openings. Okay, and I drew you a little picture there. I know you could tell exactly, but I went ahead and labeled it for you. There's my balloon. If it has just a tiny, tiny hole in the balloon, maybe it's a bicycle tire, has a very, very tiny hole in it, then again, those air molecules are able to slowly come out that tiny hole. So again, they're able to come out through that tiny opening. Okay, and that again is effusion. So again, we're going to stop right here.